Now we're going to take and finish this problem. This is our third video to find all of the complex roots for the polynomial equation x to the fourth minus 4x cubed plus 7x squared minus 16x plus 12 equals 0. So far, we saw in part B that we had two real roots. Remember, we found they were positive real roots. They were the numbers 1 and the number 3. Okay, so we're going to use that to start the factorization of this polynomial. And what we're going to have is, if we look at the synthetic division, where we ended up showing that r equal 1 was a root, that gave us numbers on the bottom that we're going to use as coefficients to start the factorization. Let me just show you, from part B, what we had. We had the bottom of our synthetic division, and if you look back, you'll see that when we synthetically divided by 1, the bottom was 1, negative 3, 4, negative 12, and 0. So I'll put this in a cloud because you have to look back at your previous video to see where those came from. Okay, so what does that mean? That means that we can start the factorization of x to the fourth minus 4x cubed plus 7x squared minus 16x plus 12. That is equal to x minus the root that we found. We synthetically divided by 1, so it's x minus 1, times, use the coefficients that are on the bottom of the synthetic division, 1 degree lower than x to the fourth. So it's going to be 1 times x to the third, and then minus 3 times the next x to the second, then positive 4 times x to the first, and then the negative 12. Okay, so we started our factorization here. But if you look back, we had another factor. The other factor was x minus 3. So let's see if we can figure out what to use for that one. Well, let's just do a little side work here to see what coefficients we could use. We know that positive 3 is going to be a root. So what we're going to do is we're going to synthetically divide this root, this polynomial here. X cubed has a coefficient of 1, then we have a coefficient of negative 3, then we have a coefficient of 4, then we have a coefficient of negative 12. Synthetically dividing by 3, which we know is going to be a root because it's a root of the larger polynomial before we started factoring it. Let's go ahead and see what coefficients we get on the bottom. Bring down the 1. 1 times 3 is 3, add you get 0. Multiply 3 times 0, 0, add you get 4. 3 times 4 is 12, add you get 0. Now, we're not surprised that we got a 0 at the end because we knew this was going to be a root. I just wanted to see this balloon right here. I wanted to see these coefficients. So what we've done here is we've taken the polynomial x cubed minus 3x squared plus 4x minus 12, and we've divided by 3 and gotten this result. That means that we can bring that result over here and continue our factorization. X minus 1 times the x minus 3 that we were just using times the smaller polynomial 1 degree higher than the third power above it. And these are the coefficients on the bottom. 1 times x squared plus 0 times x plus 4. Okay, now we've got this down to a first degree polynomial times a first degree polynomial, because inside the highest power on x is the first power, times a second degree polynomial. So the question is, can we break that second degree polynomial down any further? Yes, we can. And if you don't know how to do it, some people are really good at just looking at that and factoring it. But if you don't know exactly how to do it, just think of it this way. You can just set this factor, x squared plus 4, equal to 0, and solve to get its roots. So you have x squared equals, let's see, negative 4. So x equals plus or minus 2 times I. Okay, but what does that mean? That means that we can use these roots to continue our factorization. So let's do it here. We are equal to x minus 1 times x minus 3 times x minus the positive, so minus the positive 2i, times x minus the negative 2i, which would be plus 2i. Okay, there we go. We have first degree factors, and the thing is, doing it all the way down to first degree factors, where all the powers on the inside are all the first power, that tells us that each of these numbers that are being subtracted from x are our roots. So our conclusion is this. Remember what the question was. Go back and reread the question. They wanted us to find all the complex zeros. So all the complex zeros, all of them, are going to be these. It's curly set bracket. There was a 1, then there was a 3, then there was a 2i, and then there was a negative 2i. And those are all of them. It was a fourth degree polynomial, remember, and we found all 4 complex roots. And I wanted you to notice one more thing before we leave this. How many positive real roots are there? 2. These 2. How many imaginary roots are there? There's 2. So step B, where we were using Descartes' rule of sign to come up with a quantity of positive and negative real roots and imaginary roots, the scenario that we found was exactly the scenario on the second row that said there would be 2 positive, no negative, 2 imaginary. That's exactly what we got. And I told you that the result was going to be one of those rows. And indeed it was. And we are finished.